You know, when most people think of welding, they might picture sparks flying everywhere. But there's a whole other side to it, a more elegant side. That's gas tungsten arc welding, or GTAW. It's the secret behind the absolute strongest, cleanest, and most precise welds you can possibly imagine. We're talking aerospace parts, custom fabrication, delicate repair work. It's truly where engineering precision meets pure artistry. So, what exactly is GTAWW? You've probably heard it called TIG welding, which stands for tungsten inert gas. At its heart, it's a pretty simple idea. You create a super hot electric arc using an electrode that doesn't actually melt, and the whole time, you're bathing that arc in a special gas to protect it. It's this unique combo that gives the welder such incredible pinpoint control over the whole process. All right, so here's the game plan for this explainer. We're going to kick things off at the absolute fundamentals. Then we'll break down each of the key players, the tungsten electrode, that invisible gas shield, and the filler metal. And finally, we'll bring it all together to see how a welder takes all these pieces and truly masters the arc. Okay, let's dive right in. What is really going on at the tip of that TIG torch? Let's get to the core principle of how this whole thing works. This little diagram just says it all, doesn't it? You've got the torch, and inside is that special tungsten electrode. From the very tip of that electrode, an intense electric arc jumps across to the metal you're working on. That arc is so hot it instantly creates this little puddle of molten metal, the weld pool. And all around it, you have this invisible shield of gas flowing out of the torch, which, as you're about to see, is absolutely critical. So really, it all boils down to this four-step dance. First, you strike that arc. Then, boom, the intense heat creates the weld pool. Step 3, if you need to add more material, the welder skillfully dabs a filler rod right into that puddle. And finally, as you glide the torch along, the pool cools and solidifies right behind you, creating a single, perfectly fused piece of metal. It's just pure, controlled fusion. Okay, now let's zoom in on what's maybe the most important part of the whole setup, the tungsten electrode. This is what really makes GTW stand out. It's not really a consumable. It's more like the fine-tipped pen that draws the arc. And this right here is the whole secret. See, in a lot of other welding processes, the electrode melts and actually becomes part of the weld. Not here. Tungsten has an insanely high melting point. We're talking over 6,000 degrees Fahrenheit. So it can handle all that crazy heat from the arc without breaking a sweat or, melting into your weld. Its only job is to create the arc. Now, here's where it gets really interesting. Not all tungsten is the same. Welders actually use different types that have tiny amounts of other stuff mixed in, alloys like thorium, cerium, or lanthanum. These little additions make a huge difference, helping the arc start easier, handle more power, and just be more stable. And to keep them all straight, each one has a handy color code on the end. So if you see a welder grab an electrode with a red tip, you know it's 2% thoriated tungsten, perfect for welding steel. And believe me, this choice is everything. Let's say you're welding aluminum. You're going to reach for a pure green tip tungsten. You'll run it on alternating current, and the tip will naturally form this little ball shape, which gives you a really nice, stable arc. But if you switch over to steel, nope. That's not going to cut it. You'd want that red-tipped thoriated tungsten, sharpen it to a fine point, and run it on direct current to really focus the heat and get deep penetration. Different jobs, different tools. Okay, so we've got this incredibly hot arc, melting metal. But wait a second, that little pool of molten metal is like a sitting duck, totally exposed to the air all around us. We need to protect it. And that's where this invisible but absolutely essential gas shield comes in. It's like a personal force field for the weld. I mean, seriously, just think about that for a second. At these temperatures, the oxygen and nitrogen just floating around in the air we breathe would rush in and react with that molten metal instantly. And you wouldn't get a strong weld. You'd get a brittle, porous disaster. So, how do we solve this? Well, we blast it with a constant flow of inert gas, usually argon or helium, coming right out of the torch nozzle. This gas literally creates a protective bubble over the weld zone. It pushes all the regular air out of the way and keeps that molten pool perfectly pure. Argon is your trusty all-around workhorse. It gives a super stable arc. But helium, that's like hitting the nitrous button. It creates a hotter arc for more speed and deeper penetration on really thick stuff. So our weld pool is clean, it's protected, but sometimes just melting the two edges together isn't enough. What if you need to fill a gap or build up the joint for more strength? Well, let's talk about the ink that fills the joint. And this right here is one of the coolest things about TIG welding. Its versatility. If you have two pieces of metal that fit together perfectly flush, you can just melt their edges and fuse them. It's called an autogenous weld. No filler rod needed.
But most of the time, you need to add some material. And this is where you see the real skill of a welder shine. With one hand, they're controlling the torch and the arc. With the other, they're methodically dipping a thin filler rod into the very front edge of that molten pool. And just like with the tungsten, you have to use the right rod. They have their own classification numbers, like ER70S2 for steel or ER4043 for aluminum. Choosing the right ink for the job is non-negotiable if you want the weld to be as strong as the metal around it.
Okay, we've picked our electrode, our gas, and our filler metal. Now we get to the fun part, the power. This is where we control the electricity that makes the whole thing go. It's where the science gets really cool and the welder's skill truly takes center stage. So one of the biggest dials a welder can turn is the type of electrical current. For things like steel and stainless steel, you'll use direct current, or DC. The electricity flows in just one direction, which creates a really focused, narrow arc that penetrates deep into the metal. But for aluminum, that's different. Aluminum has this tough, invisible layer of oxide on it, so you need alternating current, or AC. The electricity rapidly switches direction, and this back-and-forth flow acts like a tiny, high-powered sandblaster. It provides a cleaning action that scrubs that oxide layer off right before the metal melts, giving you a beautiful, clean weld. And this is the result. This is what it all leads to. Look at that. On the left, you've got a cracked, damaged piece of metal. And on the right, a flawless, seamless repair that looks like it was never even broken. This isn't just luck. This is the perfect choice of tungsten. The right gas, the correct filler, and the perfect current setting, all coming together in the hands of a skilled operator. So when we ask if GTAI where engineering precision meets artistic control, the answer is a resounding yes. It's so much more than just a process. By giving the welder independent control over every single variable, the heat, the filler, the cleaning action, it provides an unmatched level of command. In the hands of a skilled welder, GTAI isn't just a tool. It's proof that you can, in fact, have both.